The other way to look at what the future looks like, when you concentrate Salton Sea water to look at the future chemistry of the sea, is what we're doing now. You can accelerate that process by evaporating Salton Sea water in my little desalination test plant down at the south end, which is connected to one of the BHCR renewables, geothermal plants. Again, they give me a modest amount of geothermal steam for free, and I use that as a heat source. And there's my larger plant that will be put in for future use. That is a very simple process. You take Salton Sea water, you flow it up here, it distributes through all these tubes. It flows down on the inside of a tube. You bring in hot steam, in this case from the geothermal plant, and you heat up the Salton Sea water to the boiling point. We operate this under a vacuum, so the boiling point, instead of being 212 Fahrenheit, is down around 124 Fahrenheit. And you get more efficient evaporation by running under vacuum. And then, so this, in the tubes, the vapor separates, and then as the brine pours down, the vapor comes off, draw it out through a condenser. That's what we do routinely at the south end of the sea. And this is what you get chemistry-wise if over a period of a day you concentrate Salton Sea water, starting here at about 90 grams per liter, and you concentrate it up, it'll just keep on. These charts are the on-site lab and analytical lab total dissolved salts, and meaning all the salts concentrated. And so you keep concentrating up to the point here of about 350 grams per liter, which is the point where you start getting salt dropping out of solution. That looks like this. Okay, and so if you look at what's in that water, this is same process, analyzed slightly different, and looking at the different ions in there. So the blue here is sodium, the purplish magenta-ish line is chloride, and you can see as you concentrate this water, you get a steady rise of sodium and chloride. That's the dominant ion species in the Salton Sea, and you also get a rise of these somewhat lesser ions. Magnesium is a steady rise. Interesting thing to look at is sulfate. It comes up, and as you get to a point where it's roughly threefold concentrated, it starts dropping down. And why is that happening? Well, there's a certain amount of calcium in the Salton Sea water as well. It forms calcium sulfate, otherwise known as gypsum. This is a Salton Sea water with a whole lot of gypsum that came out of solution in just that process. And then if we take a look at these in a slightly different way, total molarity, which is particles in the water over the total amount of particles. You see essentially the same thing here. Green and blue is sodium and chloride rising steadily, and you see you can see the calcium here, which stays low because it is coming out of solution as the sulfate rises a little bit and then starts dropping as it bonds to the calcium that comes out of solution. Let's look at, if we take the sodium and the chloride out of that, it's easier to see what's happening. So you see this red line sulfate coming up to a certain point and then dropping down, and likewise the calcium rising a little bit and then dropping down as they come out of solution. And so that's interesting because it also happens in the Salton Sea itself. This is a gypsum eruption, which we see from time to time in the Salton Sea. As the sea concentrates, it reaches that saturation point of sulfate and calcium and forms gypsum. And this is over a 15-day period in 2007 when there was a gypsum eruption, and so this light colored stuff is the gypsum coming out of solution and precipitating. So if you jump in here, which I did, and take a kayak out into it, you'll see the blue water, and then as you get here, the water suddenly turns kind of a greenish grayish color.